Okay, thanks everyone for joining on Zoom and in person. Um, Today we have a presentation from Yan Holtz. He is the creator of lots of amazing, inspirational data visualization and analysis tools, and well, inspirational but also very, very useful. And his most recent work is designing or creating a course that can kind of guide you through how to set up productive coding workspaces and workflow so that you can manage your own code well, but also communicate it well alongside the research that you're doing. So I'll let Yan kind of take over from there and go through it. But thanks very much for joining us, Yan, and presenting.
Thank you, Josh. Hi, everyone. Thank you. First of all, thank you very much for inviting me. I'm kind of in a weird situation, so I'm very sorry for this weird lightning, but it's 7 a.m. in my country, and the electronic device that allows me to enter my office is broken, so I'm basically sitting on the floor. So if you see the light turning off and I have to turn it on, that's like not usually like that. Today, but I'm still gonna try to give my best to give a proper talk. So yeah, today we're gonna talk about the intersection between data analytics and research, because researchers are data scientists kind of, without really knowing all the tools that allow us to do some proper data science. So that's why I would like to talk about the intersection between both. So yeah, my name is Yan Holtz, and my career has been a bit special because I've been working in academia for 6 years. First, I was working on the wheat genome in France. Then I've been working at UQ, at QBI and IMB about human genetics and about mental disorders. That was like very interesting experience. And then I came back to France and started to work as a software engineer for a big American company called Datadog. So as a software engineer, my work was to do code in the morning, code in the afternoon, code in the evening, code all the time. And I got like a lot of knowledge about computer science and about what proper code is. And yeah, a lot of stuff I wish I knew before when I was a researcher. Beside my work, I've always been very passionate about what I was doing. So I developed many educational websites to help people be better at data visualization. So yeah, as Josh said, maybe you know some of my websites like the R Graph Gallery that gives hundreds of examples of graphs made with R, and data2vis.com, which is kind of a decision tree where you describe your data set at the beginning and it tells you what kind of graph you should do with the data set, what kind of graph you can do, and what kind of mistake you should avoid. So if I'm telling you a little bit about my life, it's not because it's interesting, but it's to tell you that I've got some knowledge about research and I've got some knowledge about computer science and programming. And because of that, I can see that the intersection of both is very interesting. In my life, I've been struggling a lot with data analytics to make my research papers. And also I've been seeing and I've been talking with many researchers that were wasting so much time in their data analysis because data analysis is complicated. What's happening as a researcher is that you've got so much to learn about your field that you basically don't have any time left to learn about data science. However, I'm pretty sure a lot of you spend quite a lot of time doing some data analysis with R or Python, tweaking graphs, making some statistics and stuff like that. And I definitely remember being at this stage where I was spending my day analyzing data, but never learning anything about it, just learning about like the wheat genome. And yeah, I remember the good old days, and they were a bit like that. I would like open this R script that was looking like a mess and spend forever doing some manual formatting, like dealing with like line indentation and making sure everything looks kind of like aligned and looks good on my code. And then I would like start analyzing the data, and I would realize that some data look very weird. So we'll talk with the rest of the team and ask like, yeah, did you edit this file in Excel? Because there is something weird, like it just doesn't work at all. And, you know, it happened in my life a few times that like column names, for instance, would be like swapped one to the other, or maybe some row will be like slightly shifted and then nothing works in the data analysis anymore. I don't know if it happened to you, but it's very annoying and it's very sad. I also remember opening a script 1 week later, I wrote it and being like, oh my God, that's a total mess. I have no idea what I did, and basically doing it from scratch again. What I remember very well too is like spending my time making some screenshots of my charts, putting them in a draft of a publication, and then doing it again and again each time we do a new iteration of our research. And it's true for charts, but it's also true for like numbers. You're computing an average, for instance, and then you're gonna change something a little bit in like the data cleaning step, and then you have to copy the number again in your publication, and that's a big waste of time. I also remember doing some reports, writing a very good email to my boss with all my results, sending the email, and then realizing that something was wrong in my data analysis. And then I have to send an email again to say like, I apologize, what I've done is wrong. That's the true version. And that's like very uncomfortable and very time consuming. Yeah, I also remember taking the script of one of my friend or one of my colleague, and then you've got this path that links to a file into the Tom computer. Yeah, and you realize that it's not the same computer, so it basically doesn't work, and it's impossible to use the script, or you have to change everything manually, and it takes forever. What happens to you is when your boss or your colleague is editing a script on his side, but you're editing it too in your side. And at the end of the day, you get two scripts and you don't have no idea how to merge them properly. And yeah, you have no idea which script is the good one anymore. Yeah, you end up with like this kind of very special file names like script underscore final, and then you've got script underscore final underscore real.r, and so on and so on. I'm pretty sure on computers, some of you have that kind of file names. That's definitely not good practice because, yeah, in a couple of months, you will have no idea which one is the good one. What happens very often, and that's probably like the most sad situation, is when an intern or somebody in the team leaves the team and you want to run some of the script they've been using, and you have no idea how to do that anymore because it was just on the side of their laptop and it's just impossible to use it anymore. I've seen like months of work being lost because of that. So that's all very sad situations. I have no idea if you recognize yourself in that kind of situation, but I've been working with many different people and I can tell that these kind of stories are pretty usual. So the question is, how can we make it better? Do we have tools to make our lives simpler? And when I say better, I'm talking about productivity. How can we do like more data analysis with less time? I'm talking about reproducibility. I'm sure you heard about what you call the reproducibility crisis in research, where a lot of papers are not reproducible. So basically, when we run a script, we should make sure that in like 5 years, we're able to run the exact same analysis with the same results. And I'm also talking about visibility and collaboration, because when you do a research paper, you want to make sure that everyone can access what you've done properly and like use the code you've done for their analysis too. And because you want people to be able to take the code and potentially offer some modification to this code. So I know that researchers don't have time to learn data science, and that's totally normal. But my take is that in about 3 hours, probably a bit more, but around that, you can learn so much about data science that it can have a massive impact on the way you analyze your data in your everyday life. I see 3 steps. The first one is like a few best practices about code. Second one is like, instead of just writing code and then doing a report, doing your reports from code directly. And the last step is to store your analysis online, to have everything on the cloud and make sure everybody can see and collaborate with what you've done. So I'm going to talk briefly about those 3 steps. A few best practices. Here on this screen, you've got like this setwt command. Basically, it tells the computer where to go looking for files. And here it's going to look in the Holtz computer in the desktop folder. That's very bad practice, because if I give it to somebody else, it doesn't have the same path, and so that doesn't work anymore. So that's something you should basically never do, like the setwd command is something that you should never do in your analysis. Instead, you can use what we call RStudio projects, and basically when you're gonna open your script, it's gonna look for a file right at the root of where your script is. And that's it, like one less line of code. And then when you give the folder to somebody else, he's gonna be able to find the file the same as you did. So that's something you can do like in, yeah, just a few seconds, and it has a massive impact in reproducibility and productivity. Something else about code formatting. So here you've got some very dirty code. You've got like some weird case here. You've got an equal instead of an assignment operator. You've got a very big gap here. The indentation is bad. And here you've got like two comments on the same line. That makes the code very hard to read and maintain and understand. The good news is that in RStudio, you've got this very little add-ins button. And if you click on style selection, it's gonna like make everything clean for you in half a second. So once more, that's something you just need to learn once, and then you can use it every day, and it saves you so much time. Basically, I'm gonna talk a lot about R, but everything I say about R, there is the same for Python. Something else is about function. I'm sure it happens to you sometimes to copy and paste the same code and then just change one word. So basically, it's a function that does something pretty simple for all the groups. So we've got the group 1 here, which is Torgerson, the group 2 here, which is Bisco, and the third group here, which is Dream. And that's a lot of code, and it's pretty bad because it takes a lot of time. And then if you want to change something, you're gonna have to change it 3 times, which is time consuming. And it's very likely that you're gonna do a mistake and like forget one of the entry. Instead, you can just like build a function, and then so that's the function here, and then call the function 3 times. And if you want to change something, you just have to change it once in the function. Learning how to write function is not easy, but it's not too hard to. It's probably like investing about half an hour of your time to understand how it works, and then it's a gift you've got like for your entire life as a researcher. There is much more I could say about code best practices, but that's not the only topic of this talk, and I have only 25 minutes. But there is, yeah, so much more you could learn in a few minutes that could like benefit you for the rest of your life. A few packages like the tidyverse or readexcel are very convenient. Learning shortcuts is very convenient too. A few other things like that. Then there is the second part of my talk, which is how we can transform your code in something that builds a report automatically. And I don't have like my keyboard and everything, but I'm gonna try to give you a demo about what I have in mind. So I'm gonna open RStudio. You should see my screen now. So RStudio is a tool that we use to make some R code. And I would just like to show something very simple. So basically I'm gonna do like file, new file, quarto document. And it's gonna like generate a new document for me. I'm gonna call it like test. I do create. So that's it. It generates like a first template for me. In this template, I've got like a header with some features. I've got titles, I've got text, I've got links, and more interestingly, I've got some R code. So here I can put like 10 plus 10. And yeah, maybe I can try to add a little graph here. All right, and then I'm gonna click on this render button. So that's like dummy code, but you have to think that it could be your data analysis. Then I'm gonna click on render here. And it's gonna like, yeah, I have to save it somewhere on my computer. So I'm gonna call it test again. It's gonna like read my text, read my code, understand what my code means. And it creates these reports directly from my code. So you see here, there is a 10 plus 10, it's equal to 20. Then there is a code for my chart, and there is my chart. So instead of sending like just your code or just your charts to your boss or to your colleagues, you could basically build a report like that in a few minutes and send it directly to somebody. Something else I wanted to show is that we are creating a like mini website. So I can do some crazy thing like loading a library called Plotly, and then using the ggplotly function, and we should get an interactive graph from that. Yeah, so now this graph is interactive. I've got like a little tooltip that tells me what's the exact value. I can like zoom on it, for instance. I can export it to PNG. I can move the axis and stuff like that with just one more line of code. And there are like many small tricks like that that you can do to create some pretty amazing report. So for instance, if you had a few more tricks, you could end up with a report like that. So I'm basically exploring the Penguin dataset. I can put like a clean header. I can put a table of content here, some consideration here, the author with a link to who I am, clean titles, the colors you want. You can like show or hide the code, put some images. What I really like to do also is putting a table at the beginning with like the whole data set that you're analyzing. And yeah, you can like filter the data like that. You can like, yeah, if there is like one specific data point you want to understand, you can still like see it directly in the report. Some clean interactive graph as I showed, some equations, some tables, some more graphs. So yeah, that's pretty much what you can do. And to be honest, it's not that hard to learn how to do such a report. It's just a matter of a couple of, yeah, maybe hours maximum. So that was like the second part of the pipeline improvements I think we can do. And now we're going to jump to the third part because we have 4 problems remaining. So the first problem is safety. The thing is that currently all my code is on my computer. So if there is a fire, if my computer just doesn't work anymore, I'm going to lose all my work. And that's definitely something you don't want to happen. Especially when you're like finishing your PhD or something. The second problem we have is sharing, because currently the only way we have is to send the report by email. Sending by email is very annoying because if you don't send the good one, then you have to send it again. If you want to link your code with your research publication, for instance, you're not gonna send it by email to everyone. Two more problem is collaboration, because yeah, your code is on your computer. If you send it to someone, 2 people modify it at the same time, it's very annoying. And then history. There is no way that I can come back in time and see what I was doing like 20 days ago on my analysis, and maybe you're gonna do something you like, lose it, and then there is no way to find it again. That's very frustrating. Fortunately, there is a very good answer to those 4 problems, and the answer is called GitHub. What is GitHub? GitHub is a website, and it looks pretty much like that. Everybody has a GitHub page. It's like your profile page, like your Facebook page or whatever, but for code. There is like who you are, a picture, your name, your information. But the most important thing is a list of all your projects. So basically, the Penguin project I was just demoing before is going to be one project on my GitHub account. And on GitHub, a folder is called a repository or repo. That's like the fancy name we use. So that's my GitHub page with all my repository. What we're going to do is we're going to visit for real. We're going to visit it for real. So yeah, welcome to my GitHub page. I've got about 70 projects that are online, and all the websites that I've created, they are on GitHub. Like the code is hosted on GitHub. So for instance, if I check this one, data to vs, it looks like that. So that's basically like the content of my folder. So this folder, I've got the exact same on my computer and on GitHub. It's like duplicated. So if I lose my computer, it will still be on GitHub. So what I do is that I do a few changes on my computer and then I push it to GitHub. So yeah, that's like all the files. And then there is this little README that explains to people what this code is doing. And that's very convenient for visibility because then people can understand what your code is doing. And if they need it, if they want to use it, it's very simple for them to get it and use it. Something that is very convenient too is that you can click here and you're going to have a list of all the modifications I've made to this folder. So this code is probably like 6 years old or something. And you can see like all the steps that have been done. So if I click like, I don't know, maybe on this one, I can see the difference between what the state of the folder before and the state of the folder after. And that's very powerful because you don't need to do like result.final and result.final again anymore. Because what's happening is that you can track all the changes. So if you've done something but that you don't like it anymore, you can just like come back in time to the old version and you will never lose any part of your work again. Something else that is very convenient is that the little report that I've made, once it's on GitHub, it's very easy to make it become a website. So basically, this report here, you can see that it is online at this URL. And that's very convenient because what you can do now is like, you have your R code, you make a report with it, you put it on GitHub, and automatically it becomes a website. So what you can do then with your colleagues, with like all your collaborators, is you provide the URL of your report, and then you don't send any data again. If you send something, if you send an email like, yeah, I've done an update, please take a look. And 5 minutes later, you realize that something is wrong. You can like just change it, put it on GitHub. The website is going to be updated, and that's it. You don't have to write like 20 emails to say that you're sorry about it. So hopefully this little GitHub demo explain you how it works. Yeah, because of my website, I talk a lot with researchers, with like academics, but also with other data analysts. And I spend my time giving the same advice and telling the same things. So I've created a very little project where I called Productive R Workflow, where I basically teach people how to do exactly what I've showed you, but a bit more in depth. And with like all the details you need to be able to do it like on your laptop right away. I'm running out of time, so I'm not gonna give a demo of that, but if you're interested, I can show like a few lessons. Yeah, so it's called Productive R Workflow, and it's like my main focus Tuesday. I'm working like full time on it Tuesdays. Yeah, productiveRworkflow.com. So yeah, that's pretty much it. I'm Yan Holtz. You can find me on social media, like on Twitter, I'm rGraphGallery, and on LinkedIn, I'm Yan Holtz. That's a list of almost all my websites. Some of them are missing. And yeah, we'll have a bit of time to talk. So if there is anything you wonder could be great, could be better on your data analysis, please let me know. And I'm very, very happy to keep talking and see what I can do for you to make your life easier if I can. Thank you very much.
Thanks, Yan. That was really good and well done in like condensing all of that down into just 25 minutes. I feel like I could spend a few hours on each of those little topics that you talked about, going into more depth in it. Plenty of work to do after this seminar, going back to my computer. Okay, we got some questions in the chat, so I guess we'll start with them. But yep. So Gabby Sparks said, thanks for the talk, Yan. Just wondering when you first begin analysis on a project, in particular when you are exploring relationships between variables or playing around with different approaches, do you do all of this in R, or do you have a file you fiddle with code in separately?
I'm not sure I understood the question exactly, but basically the idea is when I've got a data set, what I do first. What I do first is, so I'm a bit weird, but the first thing I do is making a folder that is self-contained with like everything in it. So I'm gonna put the data in a folder called data, and I'm gonna put a new R script in a folder called R script, and I'm gonna read the data with R. So yeah, to answer your question, everything I do is in R. I never do anything else with, I never do anything with another program. And as soon as I've got this folder, I'm gonna put it on GitHub because you never know when your computer crash. Does it answer your question or not really?
I think that was good. Do we have any questions in the room? Yeah.
Can you hear me again?
I can hear you, yeah.
So my first question would be, if you're organizing the scripts in, like, pretty much you're having one directory for each project, and you're putting your scripts in that directory. So I was wondering, how did you manage the problem with environments, especially when you're sharing with colleagues? Like in our environments, with the like library versions, the package version.
The binary versions of what, sorry?
Of the packages. Like
all right. So you never put the binary in the GitHub repository. But what you do is that when you start a script, you always list all the packages that you need at the beginning of the script. And what you can do too is at the end of the script, you do a session info comment. The session info comment is gonna list like all the packages that you're currently using on your computer with their versions. So it means that somebody is gonna be able to like know all the libraries you need at the beginning of the script. And if something doesn't work properly, he can check if he has the good versions of the package. But never put the binaries in your repositories.
And for my second question, I wanted to learn more about that, like hosting the website thing on GitHub. Is there some limitations to data sets, like the size of the data sets that you can do?
So, yeah, very, very good question. Indeed, it's very common to have big data sets. There are a few alternatives. So if the data set is too big, GitHub will refuse it. But then GitHub has a special service for big data sets. I don't remember its name, but if you Google it, you will find it instantly because it's very common. However, if you have a very, very like big data, like the one we used to have for genetics, for instance, there is no way you can put like the wheat genome on your GitHub folder. That wouldn't make sense. In this case, your dataset has to be very safe on like your university server, for instance. It's not going to be on your laptop anyway, because it doesn't fit in your laptop. And then in your script, you have to very clearly state this and explain how to access this data on the university computational cluster. So yeah, depending like small data sets, normal GitHub profile. Medium data set, use like the specific service of GitHub. Very big data set, it has to be somewhere like on the server of university anyway. So just put the path in your scripts.
That was good. I've got a question, which is that say I am working on a piece of code and I want to go back to an earlier script because I think I made a mistake, and then I realize, oh no, I want to jump forward again back to the place I was yesterday, and I actually don't want to go back. Will GitHub allow me to do that? Can I kind of jump back and forward to any point in the history?
Definitely, you can jump absolutely wherever you want in the history. And something you can do too, but it's a bit more advanced, is to create some experimental branches. So basically, you've got like your main script, and you can say like, oh, I'm going to try something, and then you do a branch. Oh, I'm going to try something else, and you do another branch. And then you pick up the branch you want, or you just like forget about it.
Yeah.
So when I'm talking about GitHub and Git, I'm not talking about like a niche tool that just a couple of people are using. GitHub is used by millions of people. It's one of the biggest websites in the world. And every single developer of this planet has a GitHub account and use GitHub for work. It allows to do pretty much everything with code, and it's the only proper way not to get crazy when working with code.
Yeah. So if you were publishing a paper alongside your code, you would store your code on GitHub. Where would you do, how would you do like file control for like a Word document or something like that?
There are several options. Option one, what I used to do is that we did basically like the draft of the publication using like Quarto, the tool I've been using for the report. So basically not doing like the exact wording, but just like putting all the numbers in place that we want to put in the publication. And once this was done, we use like Word to be able to write the paper all together. So that's option one, and that's probably not the best one. Option two is basically to write the full publication using the tool that I've been using. Because when you use it, you can export to PDF, you can export to Microsoft Word, or you can export to HTML. So it's definitely doable to write the publications straight away from your data and your script.
Cool. Okay. Yeah, I guess you might run into issues with like references and things like that. Like if you're using EndNote for reference management and stuff like that.
Yeah, I didn't talk about it, but with Quarto, you've got an option where you like basically pull your bibliography and it puts like everything very clean for you at the bottom of the document. Like when you're doing a research paper, but just easier.
Cool.
I see that there are a couple of questions. How can I encourage my colleagues to use all these tools? Very good question. Very good question. It's very, very, very hard to make people change their habits. It's so hard. And I mean, I'm very passionate about code, and even it took me forever to accept to spend a bit of time learning all those tools and change my habits. So how to make them change, I don't really know, but that's what I'm trying to do every day, Tuesdays. And like, yeah, the little tricks I've showed today, usually they are kind of eye-catching, and that's very useful to make people change their habits. Also, I'm developing a online course where I'm trying to like, yeah, convince people that it's a good idea to learn all of that. So maybe show them my course and hopefully it can like help them understand that in a few hours, it can have a pretty big impact in their analysis. Also make them read like papers about the reproducibility crisis. Like sometimes researchers are very sensitive to that. They will see that it can be useful. Do you have any recommendations on how to organize folders in projects? I do, and it's actually one of the lessons of my course. So basically, what's very important, the most important thing basically is to have one folder called data, put your data inside it, and then never touch the data again. The only way to access data is through code, and you never modify the data by hand. Then have like one folder for all your R scripts, and try to make your file like going in the right direction, like 0_ beginning of the analysis, 1_ step, like next step, and so on. Because then it's very easy to understand what script needs to be run first and what script second, and so on. So hopefully that's a few recommendations. I've heard about the target package and how to manage the workflow. I'm sorry, I don't know this package called targets, so there is nothing I can say about it. And that's it. I don't have any more questions on my list.
I have one more follow-up question, I think. I really like your idea where you can use that GitHub websites to make sure like you can make immediate changes even if you make a mistake. So thank you for sharing that. I wonder if you have some tutorial pages or some keywords that I could look for to learn more about that hosting on GitHub.
About posting on GitHub, that's the question?
Yeah. I wonder if there are tutorial pages or some keywords that I could search for if I want to learn more about hosting a website on GitHub.
All right. there are plenty of like online resources. It's just hard to find one that fits exactly what you need. And the last part of the online course I'm building is exactly about that, how to use GitHub, because it's kind of tricky, like to take your code and put it on GitHub is like not really trivial. You have to use a tool called Git, and yeah, it can be a bit tricky sometimes. And once your code is on GitHub, it's pretty easy to make it becoming a website. And that's the last lesson of my course, actually. That's like what you reach at the end.
Where can I find your I was asking where I could find your posts.
My course, you can find it at productiveorworkflow.com.
Okay.
Was it the question?
Course.
Thanks.
Yeah, if you go to the website, productiveworkflow.com.
I just posted it on in the chat.
Could you do it in Python?
So currently it's only in R, but a lot of people are requesting to have the same in Python. So that's probably going to happen in the next few months. Yeah, I know, like research is weird. Half of the labs are all using Python, and half of the labs are all using R. So I started with R, but I know that I need to do the same with Python. To be honest, most of the things I'm teaching are the same in Python, just a few tools are different. Like instead of using Quarto, you're going to use Jupyter. Instead of using ggplot2, you're going to use matplotlib, and so on. But most of the best practices are the same.
So Diego said, which you kind of discussed just then, Diego said, could you share more information about the course and how to access it? Which is a little bit of what you went over, but maybe you can talk through about more what the course covers and that sort of stuff. I guess that's what you...
definitely. Just give me 1 second because somebody managed to open the door. That's much better. All right. So yeah, I can like introduce my course very quick. Yeah. So that's the landing page of my course where I explain a little bit why I did it. So it's basically my talk. Like it was a struggle for me when I was in academia, and I learned a few stuff since then. It's called Productive R Workflow. And basically the first part is about how to clean your code. The second part is about how to make a report with your code. The third one is about like making the report looks good. The fourth part is about how to use Git. Git is the tool that allows you to like make the link between the code that is on your computer and the code that is on GitHub. And the last part is about GitHub and how to make sure that your report becomes a website. And at the end of the course, you will have created this report. So basically, it's like one step at a time. I'm teaching you how to reach this state, meaning that at the end of the course, you should be able to do that kind of report with your data. Yeah, and that's like the exact like the list of all the lessons we have. So all the lessons are very small. So it's about like between 3 and 10 minutes to do one lesson, because I know that it's impossible to have like a chunk of 3 hours to dedicate to it. So yeah, we're gonna learn like how to use the tidyverse. We're gonna learn how to use like the little package that allows to format your code automatically. We're gonna learn how to make it a report, and I've tried to make it like as interactive as possible. So for instance, I've got this lesson that explains how to use Markdown. Markdown is the thing you use to make the text look good on the report. So yeah, for instance, if you put like 2 underscore, you're gonna write in bold. Yeah, and because it was a bit sad, I did like a few exercises to teach people. So here you have to write hello mate, and you see like when you write in Markdown what's happening here, what's the result, and it teaches you like how to do. So here I have to write in italic, hello mate, and so on. So there are a lot of like small exercises like that. And at the end of the course, at the end of the lesson, there is always a project to do, like the Penguin dataset. We are taking it like from the beginning to the end, and at the end of each lesson, we have to apply what we've learned during the lesson. And that's pretty much it. Oh yeah, and also comes with something I'm pretty happy about. It's a list of tips and tricks to make your quarter report looks better. So I'm gonna tell you like, yeah, how to use text formatting, how to add a table of content, how to use like automatic title numbering, and for each trick, it gives you the code and explains you how to apply it. What else can I say? That's it. Like I'm currently publishing about 1 new tip a day. So if you're interested, you can like subscribe and you will see like the new tip I invent. I'm a web developer, and when you're doing a quarter report, you're actually building a website. So for me, it's like the intersection of the two words. So it's very good fun for me to build that. Yeah, that's pretty much it.
Any final questions? Otherwise, we might wrap it up there. Thanks very much, Yan. That was really, really informative.
Cool. Well, yeah, I'm glad. Yeah, I hope like you enjoyed the talk. I hope it can have an impact on the way everyone here is gonna analyze its data in a couple of days. Who knows? And yeah, like my dream, to be honest, is that one day some like lab, like some people owning labs will like basically give this course to newcomers, like to new PhD students, new interns, to make sure they are a bit like better at their data analysis during their time in the lab. And I think it can like truly benefit the lab, because it's so sad when somebody leaves and you cannot use their code. So yeah, if you're interested in the course and wanna talk more about it, I'm very keen to talk about it with anyone who is interested. And thank you so much for having me.